Hello there. In this video we're going to talk about inverse functions, and if we're going to talk about inverse functions we have to first talk about what is a function. Okay? Now, a function is a relation in which each element of the domain is matched with only one element of the range. Okay? So if some member of the domain, which are typically the x's, is matched with more than one member of the range, or more than one y value, that means it is not a function. But that does not mean it cannot have an inverse. Okay? Now, if something is a function, okay, that does not mean that the inverse is a function or is not a function. You don't know until you mess with it a little bit. So, how do we find the inverse? Well, we've already looked at that just a little bit. Okay, and we interchange each element of the domain with the element of the range. So we switch the inputs and outputs, or we switch the x and y's. Okay, so here's an example. Okay, in this relation, I have the following 4 points: 3, 5, 5, 9, 3, 2, and 7, negative 3. In this case, I know that this is not a function because I have 3 going to both 5 and 2. Okay? I cannot have this. So because an x is matched with more than one y, this is not a function. Now, to find the inverse of this relation, all I'm going to do is I'm going to flip these numbers. 5, 3, 9, 5, 2, 3, and negative 3, 7. Now, I have to ask myself, is this a function? Well, 5, 9, 2, negative 3. None of the x's are repeated. Therefore, this must be a function. Okay, now, we also have been tasked with finding the inverse of a function given its graph. So, what I have here is a graph. It does not matter what the equation is. We can still find the inverse. Now, I've given us several boxes here with which to play, but I'm not going to use all of them. So, I will, however, use the following points. Okay? I'm going to use negative 4, 9 here. I'm going to use, and by the way, as long as I'm close, this is going to work out fine. Negative 2, 0. I'm going to use negative 1, 0. Sorry, that's negative 2, negative 1. And then I'm going to use 0, 7. So they gives me 1, 2, 3, 4, 5 points. Okay, that's going to be good enough for our purposes here. Alright, so I'm just going to list them. The order does not matter. So negative 4, negative 9. Then I have negative 3, negative 2. Negative 2, negative 1, negative 1, 0, and then we have 0, 7. Okay. This is our original function. Now, to find the inverse, all I'm going to do is I'm going to reverse these points. So, negative 9, negative 4, negative 2, negative 3, negative 1, negative 2, 0, negative 1, and 7, 0. So, now I'm going to plot them. So, negative 9, negative 4, so negative 9, 1, 2, 3, 4, negative 2, negative 3, negative 2, down 3, 1, 2, 3, negative 1, negative 2, negative 1, negative 2, 0, negative 1, and then 7, 0. Alright, so this graph looks something like this, it appears. Not my best work, but good enough for what we're doing here. So, now what I'm going to do is I'm going to look to see, hey, is this a function? Is it truly a function? Does any x value look like it's been repeated? Meaning, does it pass the vertical line test? Remember, the vertical line test says if you can draw any vertical line through a graph and it touches more than once, then it is not a function. Well, it looks like this passes the vertical line test. So the inverse is also a function. Now, you might also recall that since we swapped x and y, basically what we were doing is we were reflecting along the line y equals x. So I'm just going to draw that line in. And it looks pretty close to these points being mirrored through this line. So I not only know that this is a function now, okay, but I can also feel pretty good that I've drawn a pretty decent graph. Okay, so that's all you need for this intro to inverses. Okay, have a great night.